Okay, now we start. So welcome everybody. My name is Arno Rabold, and my mission today is to give you a brief overview of how CRA affects application development and how best to handle it. Accordingly, the title of the webinar is CRA and what does it mean, especially for application development. The broad approach today is a little bit different from typical information about CRA. Because I do not focus on CRA and mission regulation, it is more or less about the effects of the CRA on us, on everybody, on R&D and so on. So content today will be best practices, especially for CRA-compliant application development. So I'll start with motivation aspects and requirements. Then I think a focus on SBOM and how to see the SBOM, especially it is a part of the output of and scope and approach of everything regarding cybersecurity. Then best practices, requirements, general procedure, and some example logging and how CRA changes requirements and constraints for logging. So I start with the motivation and aspects. So why do we do all this? So during the initial discussions with my customers, there were frequent doubts or rather hopes that there might be a way to get around of it, of CRA and get rid of it and don't care of it. But okay, it's not about CRA. You have to see, okay, it's all about cybersecurity. Products, machines, and equipments are being targeted increasingly and sophisticated and with very subtle ways. So I would assume that most companies now have problems with incidents and with compromising contours and so on. So attacks will increase exponentially. And if you look at the liability issue, cybersecurity failure to use state-of-the-art technology constitutes also a defect, which means if you are not state-of-the-art and you don't use proper techniques, you have a problem with liability issue. So fourth is defense in depth. Do not trust any secure environment, which means, okay, you cannot say, okay, I don't have to care and everything is fine because I have a very good environment and everything is secure. No, don't trust it at all. So you have to care about it. And so as started, there's no way to get around it. This affects you and say, AI and cybersecurity are changing our world in a way fast and drastically. So don't try to get around it. So we are in the midst of a turning point and care about it. It's at the end, okay, you need conformity because there I've written there also conformity. But if you want to do it correctly, care about cybersecurity and do everything what you need to do. So cybersecurity is becoming an integral part of product quality development, lifecycle programming, and of course also of our life. I hope this is enough motivation to do it the correct way. So typical approach is going into the, okay, if you see cybersecurity is permeating every level, so it does not, it's not depend, okay, if you are operator, or integrator, or manufacturer, there's no way to go around. And okay, if you do want to do it correct, you have to look deep into this directive. But today, I will follow another approach. I will just look at the application layer and how to deal with all this directives. So today's webinar will focus on the application layer. So what does it mean? So I have tried to picture what I've been going through lately. So a starting point is the left side and the end is the right side. And starting, okay, I've tried to bring you some imagination how to see it. Okay, you have a house, you have a nice house, you have you're free to use everything. And now with CRA, you have a lot of tasks, you have a lot of to care about, and it's a starting point. Okay, it's much, and you can't focus really, and so you nearly don't know what to do. So after some time, okay, now you see it's better, but it's also a lot, and you don't see how it ends or how it should end. And say on the right side, that's this required level jump. That's the same house, but built up with more regulations, with more sorting, with more caring about that you only use, say, same things. Don't all your houses will look like this, which means, okay, you have to care about regulation, you have to care about standards. And so you decide how to handle it at the end. So you have two choices. You can do it the first time, and you can do it the first time right, or you can do it over and over again, which means, okay, if you do it right, you can say, okay, now it's fine. If you don't do it right, you have to do it the same with each project, with each product, you had to redo everything. So better to do it the first time correctly. So as a starting point, we can step a little bit back and have a look at the SBOM. So what tells us the SBOM and how the SBOM should look like? The SBOM is an inventory list of all software components, including all key attributes. It covers software and hardware, and it's essential for vulnerability and incident management, and enables us for rapid response to security incidents. So SBOM must contain software, hardware, location, customer, everything that needs to be monitored, and it is required for vulnerability management. So of course you need also the CODESYS tool, because you have to look at the CODESYS defects and vulnerabilities issues which may affect you to the tooling. So how should the SBOM be structured? So you need to have unique identifiers for unique identification, version information, description, source, type, risks, dependencies, and it should be also machine readable. And so if you look at this, it's really clear that software, okay, it's not something like software was as it used to be. So software is like a project. You have to ensure traceability, approvals, sustainability, and version control. So if you look at it, so you have to take care and you have to go on with a proper tooling to achieve all this levels. So now you may ask, okay, how to do this? So, and how I get the right rules and checklists. A good starting point are the best practices of the Microsoft Security Development Lifecycle, SDL. So there are 10 basic rules for integrating security into software development. So if you look at it, so it's training, it's security standards, it's best practices, it's cryptography standards, it's secure design, it's testing, it's development environment, it's operation platform, it's monitoring, and a supply chain. So, okay, I would say these 10 points cover a really lot aspects you need. And of course, standards are freely available and transferable. So if you don't have anything, this will be a very good starting point to look at it and to take it and to say, okay, now I have, say, fundamental guidelines for your start and for your standards, for your checklist. So 10, it's not too much. So, okay, maybe a really good starting point for you. So, of course, if you want to become better, you can just look and think about, okay, so I can learn from mistakes of others. So I can add these, say, best practices in the internet to learn from and to check each time you do implement something or you do a release. So you have here a list. It's also free available with the 10 most critical security risks for web applications. Of course, it may be a little bit different from your application, but nevertheless, you can look at it and check it. What was done wrong and what's this say as a leak and what's going on, so how you can care about. And often these questions or checks bring you from ideas what to check and how to become better. So, but what to do if we want to get even more specific? So how to categorize the security aspects and requirements? So you have to care about technology, you have to care about implementation, you have to care about processes, systems, integrity and network, and where to get some good advice or the structure to go on. And there's one recommendation from me. So the ISC 62443 provides a very good structure and answer for this question. Looking for the structure of the norm for the regulation, it's you have authentication, you have availability of resources, you have system integrity, you have monitoring of usage, you have confidentiality of data, zoned data flow and timely response to anomalies. So it's a really nice structure. And what's the reason? What's the reason for that? This structure is very good. So it's a history, because the 62443 is an international series of standards for IT security, and it's evolved during time, and it's focusing on SPS, HMI, SCADA, remote I/O, network devices, embedded devices. So it's a really good system for you because, okay, it deals with nice techniques, the question you have. So the role is a risk-based approach for manufacturer, integrator, and plant operators. And especially the 62443 is really specific, and the requirements based on security level. And what does it mean? It means, okay, this regulation are defining methods, what to do in order to reach a specified security level. And also these actions are also very good for solving real-world requirements, which means, okay, here you have from the security management your requirements, and here you have some measurements, which are also which you have also to do if you try to reach a specified security level. So this is really cool because, okay, you had just to focus on these functional requirements, and you can also solve the requirements of your security management. This is a very nice approach. Therefore, I recommend you to do it in this way. So how to go on is, okay, secure products need secure processes and secure foundation and secure organization, I would say, which means, okay, you must have a R&D environment which is secure and manage everything, which means, okay, you need to manage permissions for development environment. You need to manage external access to a development environment. You can only use approved tools. The programming code must be managed via version control tool, and permission to this version controlled systems is only granted and revoked centrally, for example, by the IT department. So it's quite, say, very easy, but okay, of course, it's fundamentally to get something good. So now it's getting a little bit tougher, but you need also basic principle and guideline for your R&D, which means, okay, here you see the typical requirements, the KISS principle: keep it simple and stupid, reduce attack surface, use authentication, authorization, session management, input-output handling, error handling, no security by obscurity. So do not base any security on secrecy. So don't try to do something on your own, just rely on really standards, because if you do something wrong and you don't use standards, it's not good for you. So least privilege grant and use only privileges that are necessary. Trust relations, so don't trust any input from other components, check against security policy and so on. So you have a lot of things to care about, but okay, if you have it in your checklist and in your policy and so on, you can have a agenda to work on. Then, okay, you can use design patterns in order to use proven solutions. So the security design patterns help you to speed up your processes, ensure your quality, which means, okay, defining permitted access, you have to prevent inconsistent decisions, you have to care about access rights and so on. So here you have also additionally inputs for your R&D, how to go on and what to care about. Now, going back to the starting point, how do we proceed? So my recommendation is use standards, use the 62443 because it's very concrete and you can really use it. Very nice. Then you have to create many guidelines, create checklists, define internal standards, manage these standards, do document, apply rules, do reviews and perform testing and so on. Which means, okay, if you want to go from the left side to this right side, you have to use these checklists, you have to use these standards in order to go on. And if you do it once, okay, it will affect the future R&D not so much as you may fear at the moment. which means, okay, using standard means, okay, you do it everything the same way. So it's a routine and you don't think about it. It's very better to be sure, okay, what I'm doing, it's okay and it's tested. And then I can go on focusing on, say, the innovation and the new technology instead of caring about the same. And because you know your basic, your foundation is good and is reliable. So I have just added a nice example. So logging is, if you're, I'm quite sure logging is something very simple, easy to do. And most people haven't thought much about logging because it's very easy and necessary. But okay, if you look to logging with CRA, especially with the categorization of the 62443, you see a lot of interference. So you have the authentication, you have availability of resources, you have system integrity, you have usage of monitoring, you have data retention, which is a new point. So you have to care about where will the data remain and how, what's the end of the life of the project and how you have to care about this data. So you have the confidentiality of the data and you have also timer response to anomalies, which means, okay, the very simple looking point of logging has a lot of critical aspects which you have to care about, which means, okay, if you want to do logging in some right manner, you should do it a little bit with more thinking about, and I think it's better to now look at it very deeply, do it once, to do implementation, to specify your logging and do it right once. So you have to care about who has access to the logs and why, who's right to generate logs, where does authentication take place, can logs contain sensitive data, can logs contain security related information, where's the logging data stored, what happens to data with the assembly, and if its assembly is repaired, and data retention through the life cycle. So, and is the data integrity required? So, and how it is ensured, and is the availability of the logging or the device of the logging checked and cared about? So, can the logging be disabled by, say, the attacker? Which means, okay, now you see, if you do it correct, you had to do it a little bit with more thinking about what can do, what hackers could do, and how to prevent it from be hacked. So now I'm also already at the end of this session, and with a bit good luck, I'm open for some questions from you. Of course, you can also contact me if you have any questions and need assistance, or if you have some ideas what to do or so. Don't hesitate and contact us. So I hope it was short and a nice description, and you get some ideas how to go on with. You're not alone. I think you have a lot of R&D which have the same tasks, and okay, just do it once correct, and then the future will be fine for you. I don't see any questions, so I wish you the best for CRA, and bye bye.